Then a little background on Matt. He got his bachelor's degree at Syracuse and a master's in zoology at the University of Maine. He's worked for the Fish and Wildlife Service in Alaska, the Forest Service, Fish and Game for 20-some years, and then Audubon, Alaska is the director of bird conservation. And Matt's going to talk about, I'll pass the baton off to him, and he'll talk about birds, and he'll talk about marbled murrelets especially, and how they use old growth forest. So Matt splits his time between Anchorage and Port Alexander on the south tip of Baranof Island. I'll point that out on a map.
I hit it.
So I think we're ready to go, are we?
We are, but could you remind folks that we should be recording this session, and just to keep that in mind, especially the folks at home, if you don't want to be on, make sure you turn your cameras off.
Okay, we're recording this session, so try not to make funny faces or say anything that might be embarrassing, but I'm sure you won't do that. So here we are, the Tongass National Forest, and we're going to take that little square on the bottom off, I think, so we can see the whole screen. And I'm going to make this thing advance. We've had, can we advance this? This isn't advancing the slide. Okay, it's advancing now. Went too far. Okay, so I'm going to start out generally and talk about temperate rainforest. Here we have the seven temperate rainforests on Earth: Pacific Northwest up in the upper left, down to Chile in the lower left, Norway upper center, Tasmania and New Zealand, and up Hokkaido, Japan. I've had an opportunity to see some rainforest in Norway, Japan, and Tasmania. Interestingly, in Tasmania, the structure of the forest looks real similar, the old growth forest, to say Southeast Alaska or Prince William Sound, but all the species are different. So the North Pacific temperate rainforest is the largest temperate rainforest on Earth. And it ranges up from the Kenai Peninsula and out to the Afognak Island in the Kodiak Archipelago, down through Prince William Sound, Southeast Alaska, and the British Columbia coast. That's Haida Gwaii in the center there off BC, right on the Alaska border, down to Vancouver Island, all the way to Northern California. And the red area are areas that have been largely cut over. We talked about shifting baselines earlier in one of the sessions, and this is a case where the southern portion, including Vancouver Island, have lost most of their old growth forest. They're just patches of old growth forest left. And that's quite different as you get up into Southeast Alaska. And I grew up in the San Juan Islands of Washington State in western Washington at the turn of the last century, 1900, in the late 1800s. Trees like this red cedar tree, which is over 20 feet in diameter, were not uncommon. There are a few trees, not this big, but a few big red cedar trees and Sitka spruce trees in Olympic National Park. But basically, these kinds of trees are gone from western Washington, western Oregon, and of course the California redwoods are just small little patches, comparatively speaking. I can remember as a little kid, you can see this tree at a roadside turnout near Marysville on I-5. And I can remember, they moved this stump, but I can remember driving through this in our car real slowly when I was, like 5, 6, 7 years old. But these kinds of forests are largely gone today. For some reason, it's not advancing. Okay. So the Tongass National Forest is really the Earth's largest national forest today, temperate, old-growth rainforest. We've got those 7 around the world, and the North Pacific temperate rainforest, that's the biggest one, but in terms of still having old growth, intact watersheds with old growth, that's the Tongass. I think we're going to need help. This damn thing isn't working. Okay. What's that? Okay, go back. I'm giving up on this. Now, I'll just say advance, please. Advance. Advance. So here are some superlatives of the Tongass. Earth's largest intact temperate rainforest. It's 16 million acres. It's the largest national forest in the United States. Has a shoreline of 18,000 miles. That's not coastline, that's shoreline. 5,000 islands, 12,000 estuaries, and very high densities of spawning salmon, brown bear, and black bear, and the highest nesting density of bald eagles and marble murrelets on Earth. So, this place is really significant. Now go to the upper left of the screen. That's Yakutat Bay. And about 500 miles down is the Canadian border. In the bottom of the screen, you can see that stub of an island. That's Haida Gwaii, or used to be called Queen Charlotte Islands. And then there's Prince of Wales Island, which has had significant logging. We'll talk about that. On the mainland from to the right of Prince of Wales, Ketchikan, and then the central islands, Kuyu, Kupernoff, and Mitkoff. Petersburg is on Mitkoff. And then going up, Frederick Sound splits the southern islands from the northern islands. To the right is Admiralty, and then upper is Chichagov and Baranof. And Sitka is on the outer coast of Baranof Island. Glacier Bay is right above Chichagov Island. So that's kind of a lay of the land. Let's go ahead. Southeast Alaska has a river discharge comparable to the Mississippi River. You've got all of these rivers and streams, even little tiny streams, coming into the Gulf of Alaska. So it's got a tremendous terrestrial, aquatic, marine interface, among Earth's highest. This is the Eagle River just north of Juneau. You can see the discharge of all of the glacial silt and nutrients and stuff coming out of that Eagle River. Next. There we go. Now this shows, it's a NASA photograph in 2002 from a satellite showing marine productivity off Southeast Alaska. And the bright green and turquoise are phytoplankton showing chlorophyll that's showing up on the photograph. And this is pushing tremendous amounts of nutrients into the Gulf of Alaska. And we have amazing salmon productivity. The phytoplankton basically make up the bottom of the food chain. Next. Millions of salmon return annually to spawn in 5,000 rivers and streams in Southeast Alaska. Next. And this is a chum salmon or dog salmon. All of our salmon have two names. Chum salmon and pink salmon are really critical to brown bears. Brown bears eat the other salmon too, but these are very, very common in Southeast. And they spawn actually in little streams that might be 10 or 15 feet wide and maybe a foot deep. And that doesn't sound like a big deal, but if you're a bear, it's really easy fishing. If you're jumping, even you and I could catch a fish like that. Well, maybe I couldn't very well. Next. So biological productivity in Southeast Alaska, salmon drive this. And you've seen pictures like this that I've shown in earlier segments. We just can't overemphasize this enough. Next. Okay, let's talk about old growth forest. How many of you have walked in an old growth forest? Oh, just about everybody. Well, there's some characteristics of old growth forests that are really essential to understand to know why there's been such a controversy over the logging of old growth forest in our country. And, you know, in Tasmania, they're fighting the same battles trying to protect old growth forests there. These are structurally very complex forests. They're steady state forests. Basically, there's unlike a clear cut or a fire where you have catastrophic disturbance over a widespread area of, you know, tens to thousands of acres. Old growth forest, you've got the death of old trees from wind throw or insects, but it's very patchy, it's very small. And the trees range in age from seedlings to some trees that get up to 1,000 years of age. And the dominant trees in these old growth stands, the older trees, are over 300 years old. So these stands are all, that's good, go, there you go. They're all ages and all sizes, from trees that may be 8 or 9 feet in diameter, and those are very rare today. Matt and I have found some of those, and they are truly amazing. Over 200 feet in height, some of them. You look at the distribution of these trees, and you can see the age structure. They're just different ages and sizes, and a tremendous understory. Next. A broken multi-layered canopy which allows sunlight to come in and hit the forest floor. And this is a critical difference between old growth and second growth. I'll show you slides of that in just a moment. Next slide. Next slide. So the abundant light to the forest floor gives you diverse and abundant forest floor vegetation, from mosses and ferns to forbs like bunchberry, dogwood, to trailing raspberry, devil's club, blueberry. I mean, these are very diverse sites. Next. So this is the bird's eye view, the raven's view of an old growth forest. You can see the broken canopy. It's not smooth. You can see the dead trees that are still standing. Those snags are really important habitat for wildlife. And you see those just big open gaps. You know, that's how the sunlight gets into the forest floor. Next. So this is northwest Kosciuszko Island on the west side of Prince of Wales and southern southeast, just right on the ocean. And there's old growth right in the middle. See how shaggy that canopy is, how broken it is, and then everything around it is second growth, different age second growth, and that canopy is very smooth. If you're a passenger on a cruise ship coming up to Southeast and you see this amazing, beautiful scenery and you see all the trees, and most people who have never walked through an old growth or really thought about what an old growth forest is don't understand that the second growth forest is just very different from old growth. And you can see right there, it's smaller and the trees are densely stocked. Next slide. So there's been logging in the Tongass since the turn of, since 1800. Just got started, and it was hand logging. Loggers with springboards cut into the base of the stumps, and you can still see stumps with springboard marks. And they're chopping, or they've got these big whip saws, and they're cutting these trees. That's how it got started. And then in the early to mid 50s, there were 2 50-year contracts with the US government. One with Louisiana Pacific Ketchikan at Ward Cove in Ketchikan, right here. And then another pulp mill and a bit mill at Sitka, Alaska Pulp Company, which was Japanese owned. And this started the big industry where they're cutting, tens of thousands of acres. Next slide. So the early goal of the Forest Service, and when Matt and I started our work in the late 70s in Southeast Alaska, this was clearly the goal. Even though the Forest Service was a multiple use agency, it was to liquidate the decadent old growth forest and replace it with young, vigorous second growth. And the plan was to get rid of this old crop of timber and grow this young, vigorous, these stands, and then when they're about this big, in 100 years or 80 years, you cut them again. Basically like a cornfield. It's a monoculture, and it has a very different effect on wildlife habitat. And a little personal anecdote. Don Schmigi was the director of the research lab in Juneau, the Forest Sciences Lab. And I remember him saying that sometime in the 60s or early 70s, when logging was really taking off and they were cutting these huge trees on Prince of Wales Island and Long Island, and he went to the forest managers. He was in the research branch. They were in the management branch, and he said, you know, we really need to protect some of these watersheds. And they laughed at him. and so, you know, in the late 70s, when we started our deer work, that was the environment that we stepped into. Next slide. So now I'm going to can we bring that down a little bit so we don't lose the top? Okay, anyway, old growth is centuries old. On the left side, that's an example. You can see the uneven age of that structure. You cut it, and then for the first 5 years or so, 10 years, you've got shrubs and herbaceous vegetation with lots of sunlight. And then by 15 to 25 years, the conifers, the Sitka spruce and the western hemlock take over, and they start to dominate the site. There, thank you, that's good. So next, I'm going to just walk you through a forest succession, starting from ground zero after a disturbance that could have been fire or clear cutting or whatever, but it's not the natural disturbance that would come from wind or the natural loss of individual trees in small patches. At 50 years old, in the middle slide, that's what a second growth forest looks like. Now, if you're a hungry deer, and you're going to walk through this area, you better pack a lunch because there's simply nothing to eat in those stands. The slide on the right is at Canalco Bay on Admiralty Island. It's where we did some of our research, measuring deer density in old growth and second growth. And there's moss that's coming in on the forest floor. There's some young ferns coming in, maybe a few seedlings of blueberry, but it doesn't look anything like the slide on the left. It's not old growth. Next. So a typical forest floor in an old growth forest on the left, and in, say, a 40 to 80-year-old second growth, 100-year-old second growth on the right. Man, just, you know, night and day. Next slide. Key point, old growth, if you cut it and you put it in a rotation of cutting it every 50 years or 100 years or 150 years or even 200 years, it's not renewable. You never get back to old growth conditions again. Now, if you just leave it alone, you'd get there. But that's not what most of the plans are, and it's not what the plan was in the 70s and 80s and 90s at the U.S. Forest Service. Next slide. Talk a little bit about deer. Matt and I and Charlie Walmo from the Forest Sciences Lab worked together, and we measured deer use in different forest successional stages. We did paired plots of a young clear cut, many young clear cuts of young second growth, and compared them to adjacent old growth forest. And there, in old growth, abundant food, reduced winter snow accumulation, and has high value to deer year round. They use old growth all year round. Next slide, second growth. There's little food, low value all year round. In some of our comparisons, there were 7 times more deer abundance in the old growth than the adjacent second growth. Next slide. Clear-cut deer habitat. Upper right, there's a deer in a clear-cut. In the summertime or in no snow winters, deer can find reasonably abundant food. There's some issues of nutritional quality, which I'm not going to get into here, but at 25 years down there, that's when the clear cuts start to move into second growth. But you can see these clear cuts on Chichgoff Island there, surrounded by old growth. Those are basically unusable in the winter. Next. This is Charlie Walmo, who's gone now, was a great mentor and an excellent deer biologist. These two pictures were taken on northern Admiralty Island, less than 100 yards apart, same day. And in the left is kind of a mid-volume old-growth forest, which has patchy snow. You can see some of the bunchberry dogwood in the very forest floor, and then some of the blueberry shrubs. And Charlie's standing in a muskeg. It's not a clear cut, but there's no forest overstory, so the same kind of issue. He's up to mid-thigh depth, and when there's more than 4 to 6 inches of snow on the ground, the most important deer food in the wintertime is buried. And have you ever punch holed through snow that deep? It takes a lot of work, doesn't it? And it costs deer a lot of energy. So when they're dealing with moving through a clear cut or a muskeg with lots of snow, it's costing lots of energy, and there's very small nutritional gain or no nutritional gain. Next. We published a paper in 1980 that got us in a lot of trouble with the Forest Service. They didn't like it, but this is a model showing upper left, in the red, carrying capacity of deer, hypothesized carrying capacity of deer. You cut it, drops way down, and then it bounces up in the early clear-cut stage, unless there's snow. And there's virtually no carrying capacity. And then it takes, probably 300 years to really start getting back the ecological conditions of old growth. And if you put it on a 100-year rotation, that bottom graph, you cut it, it drops, the carrying capacity pops up a little bit, and then it drops down and goes to 100 years when you cut it again. That's why we say that old growth on these short timber rotations is non-renewable for a lot of species, not just deer, but deer's a good example. Next. So the Tongass National Forest, largest in the United States. It's a patchwork quilt of habitat types. Rock and ice and glaciers, muskeg bogs, alpine and subalpine. 40% of the Tongass is non-forest land. A lot of people don't realize that. Take a tour ship up and you're looking out, you can see the tops of the mountains, but you just think this is a vast amount of forest. But 40% next is non-forest. And see the upper left picture, there's a little outline of red. 30% of the land base of the Tongass is what's called productive old growth forest. And most of the wildlife and fish, because fish spawn in rivers that go through the old growth forest, rivers and streams, that's critical habitat for those creatures. Next. Okay, this is a key issue. All old growth is not the same. On the left is a large tree old growth or high volume old growth. On the right is a small tree old growth. These are both, the small tree old growth is right on the edge of being scrub forest, but these are both classified as old growth forest, and they're in the timber base. The stand on the left is much more valuable for timber and economically, but it's also valuable for flying squirrels and marten and mink and deer and salmon, a whole suite of birds. And on the right, that's old growth. And some of those trees are 200 and 300 feet or 200 or 300 years old. They're Alaska yellow cedar. It's very open. It would accumulate a lot of snow, but that's old growth. So old growth ranges in different value, both economically and in terms of fish and wildlife habitat. Next slide. There we go. Tongass habitats are variable on a scale of a few acres. And you look at those kind of yellow areas in the forest, those are muskeg bogs. And, you know, Vancouver, Canada geese use those areas for nesting. I mean, there's species that move through those, deer move through those in spring and fall. But you see the dark green areas right in the center on those slopes. That's the high volume or big tree forest. And those are very valuable. And, you know, deer are using their habitat, you know, a home range in the summer might be 200 acres. In the winter, it might be 200 acres. But animals use their habitat differently and on a fine scale. Next. So we had 60 deer captured and radio collared. Actually 30 deer, and we collected over 1,000 relocations from an airplane. And you know, in the summertime, many deer would move up to high elevations and feed up in the subalpine meadows. Not all the deer; some deer were resident deer. They'd move down and use meadows. In the wintertime, when the snow came, all the deer moved into old growth forest. Next slide. And in winter, in the lower right is a deer feeding on bunchberry dogwood. It has the little red berries in the fall. You can see that out at Hillside Park. Same genus, different species. On the lower left, you can see a deer standing in a patch. There's a lot of snow in open areas, and in the forest it's very patchy, and that deer is going to be feeding around those open areas. So winter habitat selection is for the old growth forest, and they're moving from tree to tree where they find vegetation and where movement is not expensive. Next. Next. Okay, this picture is taken out of the airplane. We're radio tracking deer, and you see those red circles. This was the deep snow winter of 1982. And those red circles, you can see that forest is dense. It's old growth, it's got broken canopies, but it intercepts a lot of snow. There's very little snow on the ground there. It's patchy, and that's where the deer spent their time. They avoided, in this case, the muskeg, the open muskeg areas. And I'm going to show you a very highly selective habitat use. And the next slide is a graphic. There we go. So bear with me. The black bars, they're actually green, is the available habitat in the study area. So the scrub forest, almost 30% of the study area was made up of scrub forest. Over 30% of small tree forest. The red bars show the amount of deer use based on radio collared deer that we're locating. And you can see that, or you used to see, there we go. You can see that there's very little use of those sites. The medium tree forest, you know, the third bar to the right, over 30% of the study area is made up of that kind of forest. And you can see that deer use really increases to almost 28%. Remember, this was a high snow year, 1982. The large tree forest only made up less than 10%. I think it was about 8% of the study area, and over 60% of the deer use was in those forests. Now, that just gives you an idea. I mean, this came from real data. So deer use their habitat differently by season and by environmental conditions. Unfortunately, those large tree forests are also the most desirable from a timber harvest standpoint. Next. Very quickly, we covered bears last week. The Tongass, as you heard last week, has very high densities of both black bears and brown bears. They occupy different ranges. Black bears to the south, the brown bears on the ABC Islands to the north. Next. So again, briefly, the Admiralty, Baranof, Chichagof brown bears are a unique genetic lineage. They're distinctly different than other bears in Alaska. They're brown bears. But this is something that's really interesting, and I'm not going to get into the details, but 25% of the Alaska mammals, of the Southeast Alaska mammals, are subspecies or separate species. They're endemic. It means they're found nowhere else. And this is really a significant issue when you're dealing with island biogeography and archipelagos. You know, kind of like the Galapagos. Haida Gwaii is the same situation where you got lots of subspeciation, and you really have to be careful how you manage your habitat, taking this into account. Next slide. Seasonal habitat use, that's a winter den in the upper left. It's under a big old-growth Sitka spruce tree under the root wad. You can see where it's dug in. You know, a lot of bears on Chichagof den in those kind of dens. On Admiralty, a lot of bears actually den in rock caves. In the spring, the bear use is spread from the high elevation denning sites down through the old-growth forest, and they're out using these sedge deltas and digging up skunk cabbage roots and so on. In the early summer, a lot of the bears on Admiralty move up into the subalpine. That's where we were doing our population surveys to estimate density of bears. And then in mid to late summer, the bears, most of the bears, not all the bears interestingly, but most of the bears go down to the salmon streams. And then as fall comes and the salmon kind of leave, then the bears are moving up to high elevation to den. Next. Riparian old growth, picture on Admiralty Island, typical stream full of pink salmon and dog salmon. And this is incredibly important with the old growth forest along the border, riparian forest, and this is where the bears concentrate. Next. Okay, logging impacts on brown bears. We had 61 bears marked, and we captured over 1,000 locations from the airplane. That's old-fashioned work. My colleague Rod Flynn worked in this watershed on Chichagof and some adjacent watersheds with GPS telemetry, where letting the satellite do the work. And we found, and he and Kim Titus found, that the bears prefer the old growth habitat. Second growth doesn't have any food values, and the clear cuts create other issues. Females with cubs avoided these open clear cuts. They would avoid fishing in the riparian streams after salmon. Next. So what are the logging impacts on brown bears? Clear-cut logging reduces habitat value. We have data that support that. Roads increase bear-human interactions for hunting, for picnicking, whatever. You get into bear habitat with roads. Logging and roading increases mortality risk to bears. Next slide. This is a graphic that Kim Titus and Laverne Beyer put together. This is an area on northeast Chichagof. This is part of our study area, starting from 1978 through 1989. And the bars, the vertical bars, represent the number of bears killed in this portion of area on northeast Chichagof where there's a road system that resulted from logging. And the little line is the cumulative roads. So you can see there's a direct correlation between the cumulative miles of roads and bear kill. And you'll notice that in 1989, bear kill dropped down to very low levels. The Department of Fish and Game declared an emergency order, and they stopped hunting of bears. When you make access into bear habitat, you increase your defensive life or property kill. It's legal to kill a bear if you're defending property or life. You increase legal hunting, which you can control, like we did right there, and you increase illegal poaching. So, roads aren't really good news for bears, especially brown bears or wolves. Next. Okay, Matt, it's all yours.
Well, let's see if it works. Let me turn it on. Okay. I'll try it. We'll see how it goes. Okay. Can you hear me okay? All right, great. Well, some of this will be a little bit similar to John's, and I'll skip over that lightly so we've got a little more room for questions. This is a graph that shows the distribution of non-commercial forest land, which has 10% tree cover, but does not have sufficient wood volume to really be commercially valuable. And then class 4, 5, 6, and 7 represent increasingly larger volumes of wood or bigger trees. And the red ones, class 6 and class 7, are really where all of the commercial logging took place and still takes place in Alaska. And there's some pictures there that show the kind of forest that we're talking about with that. Let me just give it a try here. Oh, that's the laser. Okay. Oh, I see these little buttons. Got it. Okay. I should have trained on this before I got up here. There's a picture of that class 5. That's a picture of the class 5 forest. It represents about 3% of the Tongass. Optimal deer winter habitat, as John described. This is the really big tree forest. This is what you might find along the salmon streams. And this is really important for brown bears. These are Sitka spruce trees. They can be 6 to 8 feet in diameter, 200 feet tall. The understory is a little different. Instead of the deer foods that John was talking about, this has more devil's club and skunk cabbage, which are important bear foods. As he mentioned, logging targeted the rare forest types or the larger trees. The timber industry changed from cutting really big clear cuts. That picture on the left is Maybe-So Valley, and it's difficult to really tell because the entire valley, this was a mile squared large clear cut. The entire valley was clear cut all the way up, halfway up those mountainsides. And then in 1976, the National Forest Management Act changed how logging could occur. It had to be 100 acres or less. So the clear cutting in modern times is little patches of clear cut, but as a clear cut grew back to 5 feet in height, as the trees became 5 feet tall, you could put another clear cut right next to it. So it's a checkerboard of cuts, but the effect is the same, a very large patch of second growth forest. Oops, let me go back. Here's an aerial picture of the northern Prince of Wales forest. You can see the small patch cuts that are common on that part of the island. John and some colleagues did some analysis and determined that 94% of the large tree old growth, contiguous large tree old growth in North Prince of Wales was logged between 1954 and 2004. John mentioned the effects of roads on brown bears in terms of just bringing people into contact with brown bears. When you're dealing with a species like the wolf, and this is the Alexander archipelago wolf, it's a subspecies that's occurs only in northern British Columbia up through southeast Alaska. It's a smaller wolf, tends to be darker colored. This happens to be a kind of light colored wolf, but they tend to be brown almost to black. Early on, there's always been trapping of wolves in southeast Alaska, but the trapping occurred along the shoreline. In the interiors of the islands were refugia that the wolves were basically not exposed to any kind of exploitation. With the development of road systems, there is now no wolf on Prince of Wales Island that doesn't encounter a road within its home range. That's the upshot of the extensive logging and clear cutting that's occurred. And so exploitation of these wolves, because trapping, unlike a bear season where you've got, you can harvest one bear. With trapping, you can harvest any number of animals. And so there's been years where we've had very high exploitation rates of wolves beyond what's sustainable. So that's an issue, that's a concern. Oh my.
I think it's supposed to be on this side.
Oh, maybe that's the problem.
All right, test that.
Is that better? Can you hear me okay?
I don't know what's.
I can speak up too,
Okay.
okay? That's better if I don't have to hold it. As John mentioned, I've done a fair amount of work with birds. These are all birds that are affiliated with old growth forest. Queen Charlotte goshawk in the upper left, Franklin spruce grouse in the lower left. That's an endemic species. Hairy woodpeckers and other cavity nesting birds are very dependent on old snags that are common in old growth forests. Softwood, they can excavate cavities for nesting. He mentioned the very high densities of bald eagles fueled by the marine productivity of Southeast Alaska, and even a common species like Canada geese. This is the Vancouver Canada goose subspecies, nests in low volume, unproductive or non-commercial forest. Many forest birds as well. The brown creeper on the right is particularly common in big tree forests because it feeds in the deep crevices of large trees, the bark of large trees. I'm going to spend a little bit of time on marbled murrelets. This is a species that I studied for a few years. It's just, to me, a really fascinating example of an old growth dependent species that no one would ever expect to be affiliated with old growth. I mean, it's a seabird, and by definition, seabirds live at sea. So why is an old growth forest important? Well, when you look at this bird, there's a couple of really big differences from other seabirds. First of all, the color. Most seabirds are what color? Black on the top, white on the bottom. They might have a colorful beak or colorful feet or colorful plumes. This bird is really drab. It's a brown seabird, very uncommon, which gives you a little bit of a clue in terms of its reproductive strategies. Most seabirds nest in colonies on remote islands. They're on cliff faces, they're in burrows, they're remote from the land because they want to get away from mammalian predators. So this bird has a different strategy. This bird nests by itself, and it nests secretly. Okay. The bird is a member of the auk family, or the alcid family. This is a group of birds, a family of birds that occurs at high latitudes in the north. It doesn't occur in the southern hemisphere, but what distinguishes the auks from other birds is that it swims through the water. Under the water, it pursues fish by flapping its wings. It doesn't flap its feet, it swims with its wings. And it also has to fly. It flies long distances. So it needs a really specialized, it's kind of a compromise between being able to fly through the air and at the same time fly through the water to catch fish. It has to be able to do both very efficiently. So it takes a really specialized long, thin wing. So it doesn't have much wing loading. It's not like an albatross or something eagle that can soar on the thermals. It has to beat its wings more like a hummingbird, really fast, and has to fly really fast like a jet plane to stay airborne. You'll see it skipping off the water. If you do any boating in Prince William Sound, you see these birds splashing off the wave tops trying to get some height so that they can be flying. And then as they dive, you'll see them flip quickly. You can see their feet, and they dive under the water to escape a boat or to pursue fish. And they're, again, flapping the wings underwater. Think about catching a fish underwater by swimming after with your wings. The marbled murrelet was known as the enigma of the Pacific because it took a long time before people realized where it was nesting, right? The nest was it was the last nest to be described of any North American species. It was 1974. There had been a windstorm in California above a park. They sent a tree climber up to trim some of these broken limbs, and while he was up in the tree, he almost stepped on a bird. It was a marbled murrelet chick, in a nest on this limb that he was looking at. He collected the nest, collected the bird, and that was the first description of the nest. They had long heard these birds flying. We knew they flew inland. You could hear them flying through the forest, and they just assumed they were nesting on the ground somewhere and had never been found, but they were actually nesting in the tops of old-growth trees. So what is a bird looking for when it's nesting in a tree? It's looking for a moss platform. It's not going to bring nesting material into the forest and build a nest. It's a seabird. So it needs a natural moss platform. So that requires a large diameter limb, and it requires an old tree so that there's enough time for that moss platform to develop. You can see this bird sitting on a moss platform in the top of an old-growth tree. The birds lay one egg. The pair nests for life, or mates for life. They lay one egg a year. They trade off incubating at 24 hours on, 24 hours off with their mate for about 30 days until the egg hatches. You can see there's a picture of the bird on the nest. You can see how the brown coloration really helps it avoid detection. So when it's on the nest, it's perfectly quiet. You don't want peregrine falcons, you don't want eagles, you don't want ravens, you don't want some other bird coming in there and scaring you off the nest and depredating the egg or the chick. The chick hatches after 30 days of incubation. The adults will brood it for 24 hours. In other words, they'll be with the chick for 24 hours and then they leave. And the chick is left without any protection, except when the parents alternately bring food back and forth to the chick. Okay, so the chick stays very quiet. Oops. Okay, there is an adult bird with a fish. Okay, that's pretty amazing. Now, they make 2 visits to the nest. They make 1 visit to the nest initially, but as the chick grows, they'll have to come back twice or maybe 3 times. They make their runs to the nest early in the morning when it's still dusk and late at night so that they can avoid detection. They fly to the nest. They don't want predators seeing where they're going. So they have to take a really nutrient-rich fish back to the nest. They want these fatty fish. This is a needlefish, capelin, herring, small forage fish are really high quality, and they bring those back to the young. Now, I'm going to back up here just to show you. Okay. I talked about how hard it is for these birds to fly. They've got to fly 40, 50, 60 miles an hour to stay airborne. Imagine landing on a limb. How do they do that? I mean, they don't want to just smack into this moss platform. What they're looking for is an opening below a limb so that they can fly in low and come up and stall and just pop onto the nest. So they're coming in fast and low, and then they, like a jet plane, they fly up and then they just pop onto the nest. They do the same in reverse to leave the nest. They drop off and they go down and fly to gain their flight. So they need an opening below the nest. They also like to have something over the top of the nest so that they're protected from predators. They've got some cover so soaring birds aren't going to see them. Okay, this is what the chick looks like after it's lost its down, it's grown flight feathers, it's in its winter plumage. It's not a breeding bird, and all the adults will also transition into this plumage in the winter, the typical black and white. But imagine a bird that now its parents aren't training it. The parents aren't saying, follow me, I'm going to take you to the water. It's all by itself, and at some point, it knows that it's going to drop off this limb. It's going to know how to fly. It's going to fly 10, 20, 30, 40 miles in a particular direction to get to the ocean. And it's going to know what to do when it gets there in terms of, I got to catch fish, I've got to dive, I've got to swim, I've got to do all those things. It's pretty remarkable how that instinct is bred into these birds, how they know how to do that. I suspect a large number of birds don't make it to the ocean. They hit a tree, they hit a branch, they hit the ground, and then they're done. They can't take off from the ground. They need to have that drop to stay airborne. But once they do get to the ocean, a high number of them survive. They're able to find food and survive that first year. Okay, and finally, for murrelets, Southeast Alaska, the marble murrelet is a threatened species in the lower 48 because it's really dependent on old growth, which is really quite rare in the Pacific Northwest. In Alaska, it's very abundant. There's lots of moss, there's lots of rainfall, there's lots of nest sites, and it's by far the most abundant seabird in Southeast Alaska. We survey it by running transects on the ocean in boats, and we count the number of birds in a strip. We've also determined that you can aim a spotting scope across an inlet, and we can see thousands of birds flying towards productive feeding areas one way in the morning and then flying back the other way. Thousands of birds an hour flying back, carrying fish back to their nests and back to their young. It's just a remarkable daily migration. And what's even more interesting and surprising to me, I don't think anyone knows why, but these birds will fly inland to their nest sites even when they're not nesting. So in February, March, April, before they're nesting, every day you can walk in the woods and you can hear these birds flying overhead. And why are they doing that? I don't think anybody knows, but it might be just to protect the nest site. It might be to practice so that they can find that nest even when it's foggy or there's bad conditions. But for a bird that doesn't fly very easily, it does an awful lot of flying, and it flies long distances. Couple things quickly. Climate change, big topic in the press and every topic of conversation in politics. In Southeast Alaska, as the climate warms, we've got increasing temperatures, increasing precipitation in the fall, possibly droughts earlier in the summer, and that change in the water flux has a lot of effect on the salmon populations and a lot of effect on streams. You've got droughts, which results in low water levels and warm water temperatures, which salmon can't thrive in. And you've got scouring effects with floods that scour the stream beds, disturbs spawning gravel, and flush eggs out of the system. Tongass, because of the large trees, especially in that big tree component, 8% of or 20% of the national forest, of the carbon in all national forests is in the soil and in the trees of the Tongass. Half of the carbon in the above ground biomass is in those big trees. They're very important for storing carbon. John talked about the many interconnected parts of the Tongass, from the marine environment to the terrestrial environment. Big trees, lots of different species using the marine environment, the trees. I think John has shown this slide before. First principle of conservation expressed by Aldo Leopold, so the father of wildlife conservation, is to save all the parts. So even in a system where we don't understand all the interactions, saving all the pieces is really important. As a result of a lot of the work that John and others did in those days, we had some real success changing the way the forest was managed. The Tongass was managed. The Tongass Timber Reform Act in 1990 was a really interesting piece of legislation that set aside 1 million acres of additional old growth protection. It put stream buffers on salmon streams to prevent us from logging right down to the stream banks. Very good for salmon. It prevented high grading so that they weren't taking just the big trees. And interestingly, this legislation passed the US Senate 99-0. Now, can you imagine that happening today? No. I mean, 99-0, Ted Stevens voted for that legislation. And one reason he voted for it was it also came along with some mandates, like you're gonna get a whole lot of money, you're gonna get a whole lot of, but the pulp mills, which were the driving force for all the logging pressure, closed in 1993 and 1997. They closed partly because they're using old technology from the 1950s and would have been very expensive to update their mills. They closed partly because the Forest Service was putting more restrictions in the National Forest Management Act, the Endangered Species Act. There were all these new things that the industry had to accommodate when they were planning timber sales that were reducing their ability to make money. And then the Tongass Timber Reform Act in 1990 put even more restrictions on them. And so they eventually closed, the contracts were canceled, and logging is still continuing in Southeast with smaller mills, but the big pulp mills and the big clear cuts are a thing of the past. Even the Forest Service, two chiefs of the Forest Service, Jack Ward Thomas and Mike Dombeck in 2003 basically declared, we just need to stop the controversy. We're going to stop logging old growth forest. In 2015, a whole host of professional societies came out and basically made the same recommendation to stop logging old growth. Currently, in 2024, the roadless rule in the Tongass was reestablished. This is a rule that said we're not going to build new roads, which means we're not going to have more clear cuts in technically roadless areas. This is a rule that has gone back and forth with each administration. Okay, Clinton had the roadless rule. Bush did away with the roadless rule. You know, Trump put the roadless rule back in. Biden took the roadless rule. Biden reestablished the roadless rule. So this is where it is right now, but it's an administrative fix. In 2024, the Forest Service proposed a national old growth amendment to end commercial logging in old growth forest. This is still in the process of being implemented. And this is something that we never thought we'd see. The word old growth, when we started our work, wasn't even a word. I mean, these are old forests or mature forests. Old growth now is recognized for a whole host of values, from recreation to wildlife to cultural values. And this is a Forest Service brochure that's advertising the many values of old growth forest. And this is one of John's favorite sayings: our last opportunity to conserve a temperate rainforest with all of its parts, including ancient forests, salmon, bears, wolves, birds, and other old growth species. It's not perfect. It's not like it was 50 years ago or 100 years ago, but it still represents something that's quite special and unique compared to what you might have anywhere else in the world. In the lower 48, the Pacific temperate rainforest to the south of us has largely been transformed. So this does represent a pretty good opportunity. And I think that's it. So yeah, I'll turn it over to questions. We've got, 20 minutes, 15, 20 minutes for questions. If you've got any specific questions about our slides, we'll answer them, or we can just have a general discussion. Yes.
I have a question about the birds. I can't figure out what size. I mean, they're not huge because they're not huge.
Oh, what size?
Yeah, what
The marbled murrelet? Imagine a chunky robin. A chunky robin. They're about, we sometimes think of them as flying potatoes. They're kind of fat, and they're about this big. And they just, when you're watching them through a spotting scope, there's just this blur of a little fat sphere going through they're a small bird.
So just a quick announcement. I brought some books and a marbled murrelet pamphlet that Matt did with Fish and Game, and I'm going to put them outside on that table. So as you're leaving, you just take a look at it, see if you have any interest in them. And if you have a question, I'll come over and put the mic in front of you so we can get that on tape. But we're happy to answer questions. And if we get thrown out of this room, I'm just kidding, but we could go out in the lobby and answer questions that anybody might have to.
Yeah.
Any questions?
We can turn the lights up too if you want.
Oh, can you speak up to the mic on your computer if you're doing this by Zoom? Roger?
Oh, I didn't know I was being recognized. Can you hear me?
Yep.
Okay, I got two questions that you could probably talk for an hour on. One is I wondered if you had any evaluation of how the other areas on the planet with old growth temperate forest have been doing in their management. I would imagine the Japanese got started on ecological consciousness before most of the other areas. That's the one question. The other one is I was wondering when they got rid of the high grading in timber sales, I can see the rationale for that from the standpoint of trying to get some revenue out of the sale. But what's the relative benefit or detriment of high grading as far as the ecology of the area?
So I'll go ahead and hit that first question.
Okay.
Um, in Norway, there's hardly any old growth forest. It's temperate rainforest, but it's not old growth. In Tasmania, there are still some big trees, gum trees. There are like 900 species of gum tree or something like that. They structurally look like our old growth forest, but they're all different species. And they're having a real challenge. And there's a lot of citizens that are fighting hard to maintain what old growth forests still occur in Tasmania. I think that you know, in Chile, I think everybody's having trouble with old growth forest in the US. I mean, our old growth forest in the lower 48 states, in the Pacific coast, it's temperate rainforest, but you get to the East Coast, the lake states, you know, it's old growth forest too, but not temperate rainforest. You know, we're just down to patches, very fragmented. So the Tongass is really the best opportunity we have. And I'll let Matt talk about the high grading.
I might mention that you mentioned Tasmania in one of Jared Diamond's books. It might have been Collapse or another one. He reported that the original tallest trees in the world were in Tasmania. I think they were blue gum or something, and every last one of them was chopped down, whereas we've managed to hang on to a few in California.
Okay, the question on high grading was about whether the Tongass Timber Reform Act, which was meant to address that high grading issue, was very effective. And the short answer is no, it wasn't. It wasn't a complete ban on logging of big trees. Basically, the law said if 2% of your management area is big trees, then 2% of your harvest can be big trees. So it was an attempt to kind of prevent the disproportionate logging of big tree forest, but not to stop it altogether. The problem that they ran into when they actually tried to implement it was that the maps that mapped old growth forest were not very accurate. So they would find big trees that were mapped as small trees and they would log them, and they'd find small trees that were mismapped as big trees and they'd protect them. So, you know, you could game the system and it was not very effective. So I think the strategy going forward is to kind of actually do some field work and ground truth these things and draw lines around some really important stands and say these are worth protecting, and like buffer strips 100 feet on either side of the stream. That's a really clear boundary, and it works much better than some kind of mapping exercise.
One more comment. As someone who's flown hundreds of hours in little airplanes like a Super Cub at 500 feet over the forest up a valley, you know, high grading is a real issue. You see the areas that's not on a map, it looks like a patchwork of cutting, but in reality, you're flying up a valley and you've got the subalpine forest up about 2,000 feet that's not commercial, and you've got muskeg down here, and you've got avalanche slopes. So what they've cut is the good stuff, and what they've left is kind of the scrub forest. And that has a huge impact on wildlife, whether it's marbled murrelets or deer. You know, marbled murrelet habitat and deer habitat is really pretty similar for totally different reasons. And continue with questions.
There's a question online yet?
Okay. Okay. There is a group in Southeast Alaska, Richard Karstensen and Sam Skaggs, and they call it the Landmark Tree Project. And they've identified on maps where they've found really big trees. So I think if you were to Google landmark tree, you could probably get in touch with those folks and ask them. To some extent, they're kind of trying to protect them too. So, you know, okay, so that's an issue. Okay, any other questions?
Questions in the audience?
Okay. Yes.
Yeah,
Is yellow cedar
particular problem with growing yellow cedar? Can you talk about that?
Yeah, the question was, yellow cedar's having a problem, and they are having a problem. I can remember when people were seeing significant mortality of yellow cedar, and they were thinking, well, are the bears doing it, or what's doing this? And it turns out yellow cedar has very shallow roots, and snowfall is declining in Southeast, and when you have low snow and you have hard frost and it freezes the roots of yellow cedar, they die. And so I think that's the primary concern right now. It's related to climate change and the freezing the roots of yellow cedar. That's what's been explained to me by the forest ecologist on the Tongass.
Kind of a follow-up. Are the yellow cedar moving anywhere else?
Are yellow cedar moving? Yeah, I can't answer that question. There are some yellow cedar in Prince William Sound. I've been there, but I don't have much knowledge of that. Good question. Oh, okay. Rob, online?
Oh, yeah, thank you. Yeah, you mentioned that the original Forest Service policy was actually to eliminate old growth forests and replace it with monoculture. Now, the Forest Service must have all kinds of scientists and researchers. I'm just wondering, how could they have been so ignorant as to think that's a good policy? Or was it not ignorance, but the agency was simply just completely captured by the timber industry?
I'm having a hard time hearing it. I think that the speaker is saying, how could the Forest Service have been so focused on just the timber, and what promoted that? Were they pushed by the timber industry? Yes. The timber industry had a huge influence on the Forest Service in Southeast Alaska in the early days. Now the Forest Service has made a major change now. You want to?
Yeah, the reference to converting the entire forest to a thrifty tree plantation. In the post-war years, post-World War II, they were trying desperately to establish a timber industry in Southeast Alaska. And at that time, in the 40s and early 50s, it was just viewed as, what's the maximum potential for this region to grow timber, and how big an industry can we have here? There were originally three 50-year contracts. Admiralty Island was also supposed to be logged. So if all of the dreams of the early timber managers were to come true, a large percentage of the forest would have been logged. But by the time we reached the 1970s and certainly into the 80s, the multiple use mandate of the Forest Service had come to the fore. And even though there was a strong emphasis on timber management, and the budget was largely driven by timber management, they were paying much more attention to other resources. And then that tendency has just continued to shift.
Remember we talked earlier about the shifting baseline? Well, when you look at California and the scattered pieces of redwoods that are left, or Oregon and the scattered amounts of patches of old growth in the coastal rainforest, and you look at Southeast, remember I mentioned that we're about 100 to 150 years behind other parts of the country in terms of management. It gives us some opportunity. Our baseline is very different today. We've lost a lot of very valuable habitat, but we have opportunities that no one else has. And I think that's really important. And the Forest Service is stepping up. And it's amazing the old growth amendment that's in front of us now. And I might just mention, Matt and I know some folks in the lower 48 who are critical of the old growth amendment because they don't put enough emphasis on older, mature trees that aren't old growth, but will become old growth in another 50 to 100 years. So just be aware of that. But we're not in that situation. Yeah, we're lucky. Other questions? Oh.
I just wondered about spruce bark beetle and what kind of an impact it had in the Tongass, if any, and then what the forecast is.
The spruce bark beetle is not yet an issue in the Tongass, to my knowledge. It is in Kachemak Bay, where they're right on the edge of, Sitka spruce. They have Lutz spruce, which is a hybrid between white spruce and Sitka spruce. So, there are issues, and certainly here in Anchorage and South Central Alaska, but I don't think that that's an issue yet in Southeast. We've got a botanist here. Does that sound?
Yeah, it prefers to chew on white spruce.
Okay, spruce bark beetle likes white spruce. Other questions? Yes.
Earlier in your talk, if I understood you correctly, you said that when an area's been clear cut, it takes a long time, 100 years or more, for ground cover basically to come back in. Can you talk a little bit about why it takes so long for that cover to come back?
Sure. And then I'm going to hand it to Matt too. So you heard the question, why does it take so long for a forest to regain the structure of an old growth? We have natural regeneration. We have lots of rain. So these clear-cut areas are seeded in by adjacent forest. And, in like 10, 15 years, you may have conifers, this thick dog hair forest, you've heard that term, and they just keep growing, and naturally they start to thin out. But the overhead canopy for 100 to 150 years doesn't allow any sunlight to get to the forest floor. So that's largely an issue. In some cases, they're thinning these forests, which help, but thinning the forest overstory also lets in more snow. And then you have to do something with the residue. And some places have been thinned, and I've run transects through those, and it's no fun because you're climbing over and falling into, slash. But it takes a long time. Matt, you want to? Okay. Does that help? Roger.
Is catastrophic wildfire going to be coming to the Tongass?
Not yet. One of our sites on Admiralty Island was the result of a wildfire. I showed a slide of Kanalku Bay, and I think it may have been 50-acre fire that was caused by people. And of course, it ended up being a second growth forest that we worked in. But so far, wildfire isn't an issue, but who knows with climate change, where you get an unusual summer drought, and you get a fire started, but fires are not normal in a temperate rainforest. So whether it's the Olympic Peninsula in Washington, Vancouver Island, Southeast Alaska, Prince William Sound, fires are really unusual so far. But, who can tell with climate change? Does that help, Roger?
Sorry, I'm muted. Yes, thank you.
Okay, thanks.
I'll put a comment on that. In Tasmania, the climate has changed enough that the real old forests can't come back.
Very good. Thank you for that. Those are amazing forests there. Other questions? Anybody?
Yeah, I was wondering if you could speak a little bit more to the research that you guys did on marbled murrelets and what the motivation was behind that. Was it to kind of discourage logging in the area, or what was the thinking there?
I was working for the non-game program at Fish and Game at the time, and we tried to identify species that were potentially adversely affected by management. I mean, we've got a limited amount of money to spend, and so we're going to focus on those species that, in the case of marbled murrelet, it was a threatened species in the lower 48. There was a lot of concern about the species in southeast Alaska. As it turns out, we didn't realize it, but it is really quite abundant. It's actually doing quite well in southeast Alaska. So logging, it doesn't necessarily need big trees. It needs moss, and it will actually nest on cliffs where there's moss on the cliff as long as it can jump off and get airborne. So it doesn't necessarily need big trees. When it does nest in trees, it needs big limbs, and those tend to be older trees. But we haven't determined that for marbled murrelets, the logging has had a significant adverse effect, which is actually a positive result.
Do the murrelets have any particular moss that they prefer?
Any type of moss? Not that I know of. I don't think, whatever type of moss grows in the upper canopy, there's probably some kind of feathered moss, but I don't know. I don't think we've really looked at it, to tell you the truth. It's hard to get to those nests.
I have a question on the marbled murrelets. Hi, Matt. With all the dangers they face coming out of the nest and going to the ocean, what's the survival strategy of having only one egg? Why don't they have more than one egg?
The question is the survival strategy. Why do they only have one egg? Seabirds in general don't lay a lot of eggs. They are long-lived birds, so a marbled murrelet might live 25 years. So it has lots of opportunities to replace itself. So it doesn't, and you know, when you consider the effort it has to go to bring a fish to feed one chick, think of doubling that to feed 2 chicks. So its strategy is, I'm gonna lay one egg, I'm gonna do my best to get that chick fledged and successfully to the ocean. And if 3 out of 5 years I fail, at least I've got 2 successes. So that's their strategy. Yes.
I had a question too about the murrelets, and that's how they navigate through all those trees. Do they use eyesight? Or, I mean, I can just picture this little bomber shooting through the forest.
Well, you're asking a question that I can't answer with certainty, but I can't say that I've spent a lot of time on roads listening to birds fly in dense fog and snowstorms. And so it's not just even when they're maneuvering through the trees. That's one of the theories for this idea that the birds go, even in the wintertime, they're flying back and forth, is a friend of mine called it the Carnegie Hall theory. You know, what's it take to be a successful musician in Carnegie Hall? Practice, practice, practice. So that's the prevailing theory, is that they spend a lot of time flying back and forth, and they know the bends and curves, and even in fog and snowstorms, they can find their way to their nest tree. Okay, thank you very much. That's good. Yep.